Okay, this is the last video for the weekend. What we're going to do is just write the notes for 2A and 2B, which really are just looking at polynomials. So the first thing we want to talk about with transformation is how to write them and talk about points. So in general, we say for any equation as a function of x, we can write it like that. We can talk about different types. So the first one we're going to look at is dilations from the x-axis. Okay, there's other ways to say this. There is along y-axis, and another way to write it is parallel to y. Okay, so there's different ways to describe this one. Dilations from x-axis using this form are written like this. Okay, so what it actually simply means is there is a number out the front of the original function. Okay, we can just write a couple of examples if you want. So e.g. we've got y equals x squared is the original. Okay, a dilation of 2 from the x-axis, or a dilation of 2 along the y-axis can be written like this. Okay, so that's what we've got there. And we'll just write that underneath. That's a dilation of 2 from x-axis. Okay, we're going to move into the middle and just talk about that. We can talk about it as a point. Okay, so graphically, let's say we've got a point here, x, y. If you let's use that same idea here. If you dilate it by a factor of 2 from the x-axis, it means it's going this way, the x value doesn't change. What changes is y. So if I dilate by a factor of 2, what I'm actually doing is this. Okay, multiplying the y value by 2. Okay, so that's the first type of transformation that we need to understand. The second one is what we call the dilation from the y-axis. Now this is the dark side and this is hard. And we could also write it as parallel to x. Okay? And the way you can write it in this functional notation is like this. Okay? It can be written other ways. Okay? And what this means dilate, and this is what will freak you out, it's opposite what you think. It means dilate by a factor of n from y-axis. Okay? You think that's divide? You are wrong. It's times, okay? It is the opposite of what you think. Now, let's do an example of what it look at an equation. So I've got an original equation going y equals x squared. What I'm actually going to do is replace x with x on n. So what it could be is this x on 4 squared. So this is a dilation of 4 from the y-axis. Okay? And graphically, what it looks like, let's just say we've got a point. I know I haven't even drawn a graph, but we'll just talk about points. This point here, which was x, y, let's dilate it by a factor of 4 from the y-axis. What you're going to note is the y value doesn't change, but the x value is going to be multiplied by 4, and it stretches out. Okay? And we'll talk about this one a lot later with the more complex questions. Now reflections, we should be okay with reflections. Okay, so reflections, we've got a couple. We've got reflect in x-axis. So that's the one that you're probably most familiar with. That's when you stick a negative out the front of the function. So again, graphically, here's the original point. Now if I reflect it in the x-axis, what actually happens is the x value stays the same, but the y value has a negative out the front. Okay. The other reflection that we like is reflect in the y-axis. Okay, so if we reflect in the y-axis, what's different here is the negative goes out the front of the x. Okay, so graphically we can do it like this. We've got x and y. What will happen is the y value won't change, but the x value will have a negative stuck out the front of it. Okay, so what does that look like with examples? E.g., I've got y equals x take 3 all squared. A completely different graph, but y equal to f of minus x, which is a reflection in the y-axis up here. How that would look? Well, we just replace x with minus x. So there it is there. So underneath, we'll just write, or by the side we'll say reflect in y-axis. So graphically, what that would mean is the original, which is y, we've gone 3 to the right, you've got something like that, that's y. and we'll call this, I guess we'll call that y, and then we've got y2. y2 means a reflection in the y-axis. You'll get something very pretty looking like that. All right. So it's a bit messy. I know that we're taking notes here, but that's pretty much most of the transformations. The one other one to do is translations. So we're going to go back over here and do that one. Okay. What the hell am I talking about? It sounds all the same, doesn't it? But translations is movement up, right, left. Have I missed one? I don't know. So basically we've got y equals, and I'm just going to put them all together. You like these. You've done them to death with parabolas. So we'll call these translations. Okay, so underneath we can just quickly write this. We've got plus b is left. You're happy with that? Minus b is right. Apologies about the pen. Should have picked another one. Plus c is up and minus c is down. Okay, that's it. That's all the transformations. What you need to do is then put them all together. And the really important thing is the order. When you start describing them or constructing a graph from them, you need the order. It's really important. So the order is this, D, R, T. So what we've got here is dilations / reflections. Both are done at the same time. It's a bit like BODMAS. It's like multiplication and division. Like we've done the same. And then after that, we've got transformations. Okay? So your transformations, I've just got here left, right, up, down. You might want to write left, right, up, down. Okay, so in general, when we talk about the polynomials which are in 2a and 2b, so these are really the notes for 2a and 2b, what we can quickly do is to say, in general, we'll just put it all together. And I won't even give you two examples for y equals f of x. So let's say that's the original function. We've got y equals a, x minus b to the n plus c. So normally we put squared there or a cube there. We've also done a fourth. Okay, they're the types of polynomials we've looked at, but these are those things that we're talking about. So that's dilation from x left / right up / down. You may notice there's something missing. There's no dilation from the y-axis. That's that thing in here. If you want to go back in your notes, that's where that division is. We'll talk about that one later. That's a toughie. That's a dark side. It's really hard work later. Okay, how do you use it? Well, you can describe. So let's talk about a graph. E.g., describe transformations. Okay? So the order is important here. So we'll use a graph that we're familiar with, like y equals 3x plus 2 all squared. Okay? So the first thing is, in order, you do your dilations and reflections first. There's no reflections, so you've just got this number at the front. That's a dilation from which axis? When it's at the front, it's a dilation from the x-axis. So what it does is it pushes it up, stretches it up, followed by left 2. Okay? That's one very simple question. Okay, I'll keep the example simple. When you come back on Monday, we'll probably look at more of the challenging questions, okay? Now, the next one, let's talk about how to actually construct a new transform graph. So, e.g., for y equals x squared, perform these transformations. What's the time?
9 minutes now.
Actually, in fact, I might just even leave that. 9 minutes is long enough, I think. Why don't we just leave it blank there? That's all the basic notes. For the rest of the weekend, I do actually want you to try and do 2A as a minimum. And really, you should be stretching into 2B, okay? Both of them are the same. Both of them are exploring these transformations. You've done them all before, but we're looking at them a bit more. A little long, this one. Hopefully it wasn't too long for you. Okay, that is it. Thank you.